My name is Charlie Hull. I'm going to be talking about a case study in a project we've done for a UK firm using Apache Solr for recruitment search. So I'll start off just let you know a little more about what I'm going to cover. Firstly, who are Flax and who am I? The project we encountered and the solution we came up with. I'm going to be talking about how we actually did it. We built an indexer and a flexible pipeline, how the end user's UI was transformed by the project and the advantages they saw there, the performance, how we gauged performance, how we improved performance and the end results, issues we discovered, and the results and benefits to the end user. And also some conclusions and why the client have come to love open source search. So firstly, who are Flax? Well, we're search engine specialists. We've been going about 10 years now. We're based in Cambridge in the UK. We design search applications, we build search applications, we talk to people about strategy. We aren't particularly specific about any particular kind of software. We have an open source focus, but we deal with a huge range of open source software, not just Lucene and Solr. You can see some of our customers up there, some of the people we work for. We're one of Lucid's UK partners. We also run a search meetup, and there's quite a lot of these across the world now. And I would encourage you, if you're into search, and there's no search meetup in your town, to go and start one, because they're great ways to meet people involved in this area and talk about common problems and common solutions. And there's a great website, searchmeetups.com, where you can lodge your search meetups so everybody else in your area can find it. I first got into search when I joined a company called Muscat, who probably most of you won't have heard of. They were founded in Cambridge about the same time as a rather larger Cambridge software company, which you will have heard of, Autonomy, but they also did Bayesian search. And I then became the co-founder and CEO of Flax. Now, I don't just do software. When I'm not doing software, you can see examples of the other things I do here. I'm a juggler, stilt walker, trapeze artist, and I teach a lot of circus skills as well. So I don't just sit in front of a keyboard. Let's talk about the project itself. Right, the client are Reed Specialist Recruitment. They're one of the biggest recruitment firms in the UK. Every town you go into in the UK will have a Reed office. They have over 350 offices, over 3,000 employees. They also operate in Europe and across the world. They're a big traditional organisation. They've been going since the 1960s. The chairman is the son of the original founder, so they're a family business as well. They had considered a lot of options for enterprise search. They're undergoing a massive restructuring. And their issues are a huge amount of data, a rather old and complicated database schema. And this is the interesting thing. Because they're going through a massive redesign of their whole IT provision, this is an initiative led directly by the chairman's office. We've got a situation where we've got a massive Oracle database with literally hundreds of fields in the scheme of that database. And we've got to transform that data into something we can put into Solr. But that's all going to change in a few years. So there's no point us having an inflexible solution that just works with the Oracle database as it is today. As I say, hundreds of millions of items. These are rows in the database. They've also got CVs or resumes in Word and PDF format as flat files stored in the file store. There's multiple languages. We've got, there's English, obviously, Polish, Arabic, Chinese. So it's quite a complex problem. The problem with the existing system, again, an Oracle database, and they have their users who are their recruitment consultants, the guys who sit there trying to get jobs for other people. They have applications built on top of their existing Oracle database, but these are pretty elderly, to be honest. You literally type in a search, and you can go and make a cup of tea, because it will take minutes for the results to come back, and the results probably aren't going to be ordered in any kind of useful fashion. So we also got the problem, there's over 3,000 users very familiar with this system. And not all of these users are particularly computer literate, but this is the screen they sit in front of every day. They're used to how this works. There's also no real foundation for innovation here. Now, Reed have got ambitions to do much bigger things. Once they can search their data effectively, there are obviously things they can do on top of that. They want to do analytics. They want to really tie how their business works into how the search engine operates. So there's lots of reasons they wanted to make this change. They considered some of the biggest closed-source commercial search engines, but luckily we managed to convince them that the open source route was the way to go. So why did they choose Solr? Well, firstly, they wanted something that was flexible and extendable. This is only the first wave of development for Reed. We are actually now engaged with them on a second wave, and there's lots of great ideas for the future. Now, because of the nature of their business, because how well they place a candidate in a job, the commission they get from that directly drives their profitability. Really, getting the right people in the right places is directly linked to how much money their business makes. There's some very complex business rules engaged in this system, and so they were very interested in the idea of boosts and function queries and all the things that Solr gives you as a way of reordering data and really giving their recruitment consultants, their end users, some very accurate and properly ordered results. They also had the problem that, again, this is only the first wave. We've got tens, hundreds of millions of items now. There's going to be more to come. You know, we haven't touched email, other file stores, other records they have. So they needed to be able to predict the cost of the search in the future and whether the system as a whole was economically scalable. I think this is a very important point. If you look at a lot of closed-source commercial engines, quite hard to predict what they're going to cost next year, especially if they've just been bought. So Solr was very much an option there because they could see a way of predicting that. Also, of course, they wanted support, and they wouldn't have really gone for Solr if there hadn't been commercial support options available. So, firstly, I'm going to talk about the problem we had, this massive monolithic Oracle database, over 300 fields in the schema, huge amounts of data. How do we get that data into Solr? Now, there was a previous talk in here earlier today, Jan Hoydal, talking about the way of doing this in Solr itself. Now, we decided not to do that. We did something a bit different. So firstly, we built an indexer, not surprisingly. Now, the way this works, it has a settings file written in XML, you might expect. It extracts data from that Oracle database, processes it if necessary, and puts it into a Solr index. Fair enough, pretty obvious. But there's also a second component to this. There's what we call a config tool. What this does is takes the settings that indexer reads, that XML settings file, and builds a Solr schema. But it also, very importantly, does some verification and conflict checking. There's no use building this kind of indexer or processing pipeline if you've managed to set it up so you've extracted one field from Oracle, put it into Solr, extracted another field from Oracle, and overwritten by mistake that same field in Solr. So this gives you a way of verifying the whole chain all the way through. Now, I'm not going to say this is the only way we could have done this. This is just what we came up with, and it seems to work pretty well. So how does it work in practice? Well, we've got our Oracle database and our CVs on the left-hand side there. This is the content the user has. And our XML file defines two types of things. There's actions and processes. And very broadly, actions take data out of Oracle or out of the CVs, and processes mess with that data, combine that data, and then it eventually goes into your Solr index. So some examples of how this works. The simplest example is a copy action. All this does is say, from this column in Oracle, take data, put it into this field in Solr. Very simple. But there's other types of action as well. There's a CV action, which takes the data, the plain text, out of a candidate CV and puts it into a text field in Solr. Now, we used Apache Tika to actually extract data from PDF files, Word files, etc. We chose not to use the updating index handler stuff, and the way you can actually have this all done inside Solr, because we like Tika where we can see it, where we can manage it, where we can make sure it doesn't run out of resources or fall over. And in general, processing PDFs, docs, whatever, in our experience, most of the solutions out there for processing these files, you can break them with the correctly applied PDF file. So we like it where we can see it. We like it outside. So there's a CV Tika source action here, which basically handles that whole operation of using Tika to extract plain text from a document. We've also another action here. This is the CV Solr source action. This is where you've built a Solr index with all your pre-processed data from CVs, all the plain text. You've got to do a reindex now. You don't want to have to go through that whole process of using Tika again. So you can literally just copy the plain text out of an existing Solr index into a new one. We also got actions on the other, processes on the other side. And these basically take the data we pulled out of Oracle and combine it, recombine it, and process it in a certain way. And one good example of it is a most recent date process. We've got several date-related fields in Oracle. Remember, we've got 300 fields in Oracle. In fact, there's a lot of dates. But we only want to input into Solr what we call the most recent date for this item, this object. So very simply, a most recent date process takes two dates and takes the most recent one out of those dates. So there we go, actions and processes, all defined in an XML file. But this doesn't say anything about the Solr schema. So the config tool I mentioned, these blocks in orange here show you what this does. That takes this original XML file, defining as actions and processes, and builds a Solr schema out of it automatically. So we don't need to hand code that. And also carries out these very important verification steps. It does things like check types for being correctly done, so you're not putting some string data into an integer field, for example. It makes sure that there's no conflicts between the ways the actions and processes work. They're not fighting each other. And so that's a pretty high-level description of the whole way the indexer works. Data comes out of CVs and Oracle, comes out by actions, is processed by the processes, and goes into a Solr index according to a Solr schema that's also generated from that. And the advantage of this is that we can see how it all works, it's all verifiable, and when we do have the problem that Oracle all changes in a year or so, we can go back and repeat this process relatively easily and still get us up into our Solr index. So let's have a look at the actual code, how it actually works. These are pretty much cleaned up examples of some of the XML. Top there we have the copy action, and as you might expect, there's a column in Oracle and a field in Solr, and literally it just pulls out of one straight into the other. Processes. We've got the most recent date process down the bottom here. There is beans and bits of stuff there that are relevant, but you can see there's two dates here, an update date and a create date, and all we're going to do is take the most recent one of those and put it into a field called boost date. Now, of course, there's more things in a Solr schema than this, and if we're going to process this and create a Solr schema from it, we're going to have to add in lots of other stuff. So you can mark up this as well with Solr-related stuff, such as types, whether we're going to index this data, whether we're going to store it, all the kind of stuff you're very familiar with by looking at Solr schemas. And this flows all the way through. The config tool reads it and passes it through to generate the Solr schema. But this is the definitive document that defines how you're going to get data out of one end and put it into the other. And this is what kind of Solr schema pops out the other end, as you might expect. We can see email there, and the markup I put in, and the boost date and the markup I put in coming through and producing a Solr schema. This is the old UI at Reed. This is what their recruitment consultants would sit and stare at all day. A few salient points here. Total number of records, 500. No particular ordering of those records, so you just have to go through them all until you found someone that looked vaguely like the person you wanted for that job. Lots of magic numbers and codes there, which don't mean anything to me, and probably won't to any of you, but obviously meant something to the consultants. They had some kind of way of splitting up this data into jobs and candidates and managers, but it was all pretty primitive. And again, this is running on a set of thin clients at their offices. And as I said, literally, it was a case of set it searching, go and make a cup of tea, come back and get some results. Pretty painful to use. But remember, people were used to this. They were happy using it. So here is what we had as the new UI. Now, hasten to add, this was actually developed by Reed themselves. When we discussed the project with them, because they know their end users, they decided to take on this task themselves. We built their Solr index for them, and they just literally pulled all the data out of Solr to do this. So it's still pretty complex, to be honest. It's not the cleanest, simplest UI, but it's got a few new features which they couldn't do before. You can sort the results. How about that? We couldn't do that before. You can sort them by the last updated or by relevance or any other fields we've specified. You can expand the results. You can see the top one there is expanded, so you can see a quick list, and then you can expand and drill into them. They had an interesting thing with this because they had the facets, and everyone went, oh, that's very well, but nobody was using it. They had no idea what it was for. And so they had a massive retraining exercise. They had to go around and say, well, you know when you go to Amazon and you search for a television and you get brands, Sony, Samsung, whatever, just like that. And there's a huge sort of, oh, we've got that, marvelous. So they've got facets now, so they can filter the search results by facets. This may seem incredibly obvious to a lot of you, that this is the kind of way you build a search user interface. But of course, to some of Reed's end users, they're not used to this. They're locked into the application they've been using for years. We've also got, this is part of the training, is actually having top tips to tell you that with this new magic search interface, you can do these really clever things like wildcard searching. And this is part of their training exercise to get people moved over to the new system. They have top tips. And they've now got a tabbed UI, so if you are searching for data within certain groups, you can search in just candidates or just jobs, whatever. Another way of splitting up the data there. So they're pretty happy with this. Now, performance. Obviously, this is something we run into with most search jobs. As we all know, there's many factors that can affect this. So how do we deal with that? Well, we built a test framework as part of this to make sure we could test performance as we went along, really from the very beginning of starting a project. So the way we approach this is we randomly generate queries based on terms in the index. It's not much use producing lots of queries that are going to produce no results. So we want ones that can produce some results. And we can record the average query times, number of results, etc. And this was particularly useful when we were tweaking boost functions to work out exactly how results were being returned and comparing one to the other. Performance, well, sad to say there's now no time for a cup of tea. We've gone from minutes to get search results down to sub-second. This is all running on a single server. They'd provisioned several more. We didn't need them. This is all running on a single server. In fact, it's so fast that the thin clients I mentioned, there's so much more network traffic now that they had real issues with the thin clients. They've had to upgrade their thin client architecture to cope with how fast the search engine is, which is strangely satisfying. But there's still work to be done. The indexing speed isn't as fast as we would like, and we're now beginning to really zero in and tune the way we're using Solr to try and make that faster. But in terms of performance, they're pretty happy. Issues both we and Reed encountered during this project. Users don't understand their new freedoms. I think, when I go and see people, that everyone uses Google for everything, and they're so used to everything coming back like that, with everything being magic, and it's almost like an annoyance that clients just want a Google, please. But actually, a lot of users don't understand they have those freedoms. They don't understand what they can do with the new search engine. So we needed to train people. Reed launched a massive training exercise for every one of their offices to show people how to use the new system. They didn't know about wildcards. They didn't know about facets. And don't underestimate how hard it is for a user who's been locked into one application for years and years and years to go to a new one and understand what they can do. In fact, they probably won't try all these new features in case it breaks something. And then they'll get blamed and they'll get in trouble and they won't understand it'll all be their fault. So people don't necessarily like to click all the buttons. Hackers do. We love playing with systems, exploring them, seeing what works, but end users don't necessarily do that. Any issues like this, where they can't find the jobs or candidates, possibly because they're just not clicking the right buttons, reduce their confidence, and they say the new system is worse than the old system. Actually, it's better, they're just not using it right yet. But that's not their fault. Maybe they've not been trained sufficiently, or maybe just haven't made it obvious enough in the UI. Another thing we came up with, something that bit us a bit, was we were having bits of Solr conflicting with each other. Now, Solr's full of these marvelous features, and there's things like, for example, synonyms is a good example where we had a bit of a problem here. Reed had an internal set of synonyms for different job descriptions. And some of these weren't as well organized as you might expect. We had trouble with stop words. Classic stop word is it. But then you've got IT, which is obviously quite a large area of recruitment. The two can fight with each other. How do you do the default sorting? How do you bias recency over relevance? Is the most recent CV from someone more important than more? Just if you're looking for a C programmer and you get a van driver just because he submitted his CV 30 seconds ago. Now, we basically came to the conclusion that the sensible thing to do is get the basics working first and then start adding up the clever stuff. It may seem obvious, but certainly don't develop everything at once and turn it all on at once. Get the basics working first and then add things incrementally. What were the results? Well, we're glad to say we managed to deliver this on time and on budget. That's us and Reed. And it went live across their 350 offices. I think, to be fair, it actually went live the day after it was planned, but because it had been planned on that date 6 months before, we did pretty well, we think. Went live in July. They have 24/7 365 support for Solr provided by Lucid. So they're covered at that, in case it all goes wrong at 3 in the morning on a Sunday. And I think I can safely say that Reed are very happy, which is always nice to hear. So what were our conclusions? Well, from our point of view, we learnt that this flexibility in the indexing pipeline is absolutely essential, especially when you're dealing with a situation of a pretty old legacy database architecture, which is going to change in this weird way. It's going to change from underneath us. At some point in the future, we're going to have to cope with that. Get the basics working first. Make sure you've got your basic search working first and then start adding bells and whistles. Don't be tempted to turn everything on from the beginning. What did Reed learn? Well, user training extremely important. Even if the new system appears to be simpler and more powerful, the users won't necessarily get that. But they have learnt to love open source search. Remember, when we originally went to Reed, actually, before I went in to talk to them, all they had considered was closed source commercial search engines. They haven't even looked at the open source options. And so this was a bit of a push for them to actually go this way, and we're very glad they did. They are a traditional business. They're in a recruitment sector. They have IT departments, but the IT department is running great big Oracle servers. They're not necessarily familiar with this new world of search. But the conclusion we've had, and this is a direct quote from them, they're pretty happy. This is all corporate speak here, but it's basically saying that they are happy they chose open source, they're happy they chose Solr, and it's step one along the road. But we are certainly of the opinion that Solr was the right tool for the job here. Thank you for listening. There's all my details. Thank you very much. Okay, well, one you're asking about that there's a Solr patch for patching, for connecting benchmarks back into Solr. One issue we had actually with this project is, again, the organization aren't particularly familiar with open source. And if you go in and say, there's this fantastic open source product, there's this released version, is it 3.4, 3.5 with Solr now? Or there's 4, there's trunk, and a zillion patches. And they weren't particularly happy with the idea of a heavily patched open source project. They're coming around to the idea. They now have staff actually trained on Solr, so they're beginning to get their heads around it. But they were far more happy with a few patches as possible. And again, this refers back to Jan's talk earlier, where the updating index handler stuff, well, a lot of it is basically patches to trunk. It's not released, and we all know that basically a lot of these patches are fine. They're perfectly stable, they're lovely, but trying to convince a client of that who are just making their first baby steps into the world of open source is a difficult battle sometimes. But I'll certainly look into that. Please contact me if you want to know any more. Thanks very much.